Hey everyone, welcome to this tutorial on linear regression. Today we are going to dive into one of the fundamental techniques in machine learning and statistics. Whether you are new to data science or brushing up on the basics, this video will give you a solid understanding of how linear regression works and how to implement it in Python. So let's get started. We'll first start with the definition of the linear regression, and it says, linear regression is a method used to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation to observed data. So in the simplest form, the linear regression equations has a representation of something like this. So linear regression aims to find the best fitting straight line through a set of data points. And this line is represented by the equation y equals to mx plus b. So let's divide and see what are each component of this equation is. Here y is the dependent variable, x is the independent variable, and m is the slope of the incline, and b is the y-intercept. So this equation shows the relationship between the input x and the output y. And the goal is to find the value of m and b that minimize the difference between the predicted value and the actual data points. So imagine you have a data set where you are trying to predict a person weight based on their heights. And the linear regression model will try to find the best line that minimize the difference between the actual weight value and the predicted weight value. And the difference is often called the residual error. So to understand how the linear regression works, let's break it down further. We need to minimize the error or the difference between the actual data point and the value predicted by our model. This is done by minimizing a cost function called mean squared error or MSE. So this is the formula of mean squared error. And here the yi means this value is the this value is the actual value, and the yi with the hat is the predicted value. And the n is the number of the data points. So by minimizing this cost function, the algorithm adjusts the parameter m and b to make the model's prediction as close as to the possible to the actual data, means this value, the also called the observed value, and this is called the predicted value. So now let's take one example to understand the linear regression. So in this, we'll first import our libraries. So I'm importing here NumPy, Matplotlib for the visualization, and scikit-learn, which is the popular machine learning library. So first, after importing all these libraries, now let's generate some sample data. So we'll stimulate some random points of heights and weights. So let me run this cell. So here I'm taking the seed as 42 for, so we can reproduce the same results. And first let's create the heights, which is the using the random normal distribution data, which is 160 is the mean and 10 is this standard deviation, and total 100 points. Similarly, the equation I'm creating for weight is zero point 0.5 height plus the normal distribution of 0 mean 5 standard deviations and total 100 points. So let's see how this data looks. So if I just run this is our height data. And if I run the weight, this is our weight data. Now let's visualize the data to see what we are working with. So I'm using the calling the matplotlib library here, and with the scatter function, this is the data, how the data looks. As you can see, there's a general uptrend. The taller the person, so this is the height and the weight, the taller a person, the more they weigh. So let's now fit the linear regression model to this data. So to fit the data, we need to or transform our heights and weight into, so we are converting here our one dimensional array of heights into two dimensions. So we are using this code to reshape our data sets of height and weight. And after transformation, this is how the data looks like in the 2D form. So this is the 2D array. Next step is to create the instance of the linear regression and use the fit method to train the model on our data. So if I just run these two cells, so this I'm just creating an instance of the linear regression and fitting the height and weight. Now let's plot the regression line along our data points. So I'm just adding the regression line here with the height and the predictive value of the height with color and colors red and the line with S2. As you can see, the red line represents the best fit line predicted by the model. It captures the overall trend of the data quite well. So quite is, as you can see, the higher the weight, higher the height, more is the weight. And let's now understand the model output. So let's take a look at some of the properties of the model and especially the slope and the intercept. So after running the model, we can call out the slope and the intercept into separate variables, and this is our values. The slope tells us how much the weight increase for each centimeter increase in the height, and the intercept represents the predicted weight when the height is 0. So in our case, the model should give us is given us around value of around 0.5, and which makes sense since we generated data with that relationship. And the intercept might be the small value which is close to 0, and since the weight value are somewhat proportional to the height. So now let's evaluate how well our model perform using some common metrics. So we'll check the R squared value, which tells us how the model explain the variance in the data. So I'm calculating the R squared values here. So an R squared value close to 1 means the model explain the most of the variance in the data. A value closer to 0 means the model does not explain the data very well. And that's what the basic introduction to the linear regression in Python. So we have learned how to fit the model to our data, visualize the result, and evaluate its performance. So linear regression is essential tool in statistic and machine learning, and understanding it is the key to explore more complex algorithms. So if you enjoyed this video, make sure you like and subscribe for more tutorials, and let me know in the comments if you would like to see more similar videos. Thank you for watching, and see you the next time.